Imagine this. You're sitting in a high school classroom in northeast China. The only sound is the quiet scratching of pencils on paper, students hunched over exams, deep in focus. Then, out of nowhere, the ground jolts beneath your feet. Desks rattle, windows shake, outside cracks spiderweb across the concrete playground like something alive is clawing its way up from below. Was it an earthquake? Not exactly. Because at that very moment, 1,500 miles away, seismometers across the planet lit up like alarm bells. From Tokyo to Stockholm, from Washington to Moscow, scientists stared in disbelief. A magnitude 6.3 event had just originated in the heart of North Korea. But this wasn't tectonic, it was artificial. Someone had just detonated the most powerful nuclear weapon in North Korean history, and in doing so, they moved a mountain. Welcome to Mount Mantap, an ancient granite peak standing 7,200 feet tall in the remote northeast of North Korea. Cloaked in mist and mystery, it looks like just another mountain, but beneath its surface, a hidden world of tunnels and secrets carved out by military ambition. This is the Punggye-ri nuclear test site, a place so tightly guarded that even satellite images struggle to tell its full story. For more than a decade, this site has hosted some of the most dangerous experiments on Earth. Within the mountain, engineers had carved a labyrinth, 3 main tunnels or portals, south, east, and west, hook-shaped, deep, each designed with one terrifying purpose: to contain the uncontainable. And on September 3, 2017, containment failed. Early that morning, deep beneath Mount Mantap, some 4,700 feet below the summit, technicians prepared to detonate what they called a device. But this wasn't just any nuclear bomb. It was a thermonuclear weapon, a hydrogen bomb, capable of releasing energy equivalent to 250,000 tons of TNT. That's more than 16 times the power of the atomic bomb dropped on Hiroshima. At exactly 12:36 p.m. local time, the device detonated. In a fraction of a second, the bomb vaporized everything in a chamber the size of a football stadium. Granite that had existed for millions of years turned to plasma. Temperatures exceeded the surface of the sun. Then came the shockwave. The force radiated outward, fracturing rock up to 1,000 feet in every direction. The entire mountain, billions of tons of solid granite, lifted 6 feet into the air and was shoved more than 10 feet sideways. Think about that. A mountain, moved by human hands. Within minutes, seismic stations across the globe confirmed the impossible. North Korea had just set off a hydrogen bomb, a man-made earthquake unlike any other. In Chinese border towns, lunch tables shook. Office workers ran from buildings. That classroom full of Chinese students, they were dismissed immediately when the cracks in the ground outside began to grow. And the fear wasn't just about the blast. It was about what might come next. Seismologists at the University of Science and Technology of China reviewed data from 112 monitoring stations. Dr. Liu Junying, who had tracked every North Korean nuclear test since 2006, saw something that chilled him. The seismic signature, he said, wasn't just stronger, it was different. This test had fundamentally reshaped the Earth, and he meant that literally. Just 72 miles away, another mountain loomed, Mount Taektu, known as a sacred volcano. It last erupted in 1903. But its most violent event was far earlier. In 946 AD, Mount Taektu exploded in one of the most powerful eruptions in human history. It darkened skies, disrupted climate, spread ash across East Asia, and now it had been shaken awake. Dr. James Hammond, a British seismologist, had spent years studying the volcanic systems beneath Mount Taektu. After the North Korean test, he and his team ran simulations, and what they found was alarming. The bomb's shockwave had traveled directly through the Earth's crust and hit the magma chambers beneath Mount Taektu. Imagine a bottle of champagne, Dr. Hammond explained. You shake it hard enough, the pressure builds. Eventually, it only takes a tap to blow the cork off. The nuclear test might have been that shake. The volcano had remained quiet for over a century. Now, the ground beneath it was shifting. In the hours after the explosion, satellite images of Mount Mantap began circulating, and they were terrifying. Before the blast, pristine ridgelines, untouched forest, a mountain as it had stood for millions of years. After the blast, scarred earth, fresh landslides, jagged fissures radiating from the blast site like lightning bolts frozen in stone. But there was one detail that truly stopped scientists cold. Mount Mantap was shorter, by nearly 20 inches. A peak that had been unmoved for millennia had physically shrunk. The mountain had expanded, lifted, and then collapsed inward on itself. And the collapse didn't stop there. In the weeks that followed, Chinese researchers monitoring the region noticed something even more disturbing. The mountain was showing signs of what they would later call tired mountain syndrome. It's a term once reserved for Soviet nuclear test sites, used to describe what happens when a mountain is bombed so many times from within that it begins to fall apart. The rock fractures, the pressure vents, internal chambers collapse. The entire structure becomes unstable, like a hollowed-out eggshell. Dr. Wang Liangjing, a geologist studying the satellite data, put it bluntly. Multiple underground explosions have shattered the mountain's core. The entire peak is compromised. If Mount Mantap collapsed completely, the world wouldn't just be watching a geological disaster. It could trigger a radioactive nightmare. You see, the tunnels inside Mount Mantap, those twisted, hook-shaped channels, weren't just clever engineering. They were traps. Designed to contain radioactive material after each test, the idea was simple. Seal the bomb in, blast it, and let the mountain bury the fallout. But with the mountain cracking open, all that material, decades of it, could escape. Wang Nanyun, a nuclear scientist with the China Institute of Atomic Energy, didn't sugarcoat it. If that mountain opens up, the rocks will release everything they've held inside, like steam escaping a pressure cooker when the lid comes off. And the winds? They wouldn't stop at the border. Chinese scientists began collecting air and soil samples across the border. Radiation monitors were deployed in schoolyards, on rooftops, and deep in the forests of Yanbian. At first, the results were calming. No detectable leaks. No radioactive clouds. Yet. But the fear remained. In South Korea, just 200 miles from the test site, the public wasn't waiting for official word. Protesters flooded the streets. Parents marched with their children. Students held signs that read, "You crack the earth beneath our feet." This wasn't just politics anymore. It was personal. What came next shocked even the most seasoned scientists. Over the next 8 months, long after the headlines moved on, the earth around Mount Mantap kept trembling. Between September 23, 2017 and April 22, 2018, more than 10 aftershocks were recorded around the blast site. Each one small, magnitude 2.1 to 3.4, but every one told the same story. The earth was still adjusting, still collapsing, still groaning under the weight of what had been done. Dr. Paul Richards of Columbia University's Lamont Doherty Earth Observatory explained, "It's as if the mountain is still trying to find balance. The test fundamentally disrupted the region's geological stability." And if you're wondering whether these tremors could trigger more than just local landslides, you're not alone. Volcanologists had their eyes firmly on Mount Pektu, because the mountain wasn't just tired, it was broken. Mount Pektu hadn't erupted in over a century, but geologists knew its magma chambers were still active. The aftershocks, the shifting crust, the rising pressure, it was like slowly twisting the cap on a shaken soda bottle. No one knew how many turns were left before it blew. And so, China launched Project Chongbai-Shan, a massive monitoring operation near the North Korean border. Seismic arrays, GPS sensors, gas emissions trackers, all designed to watch a sleeping dragon and listen for the sound of its stirring. Dr. Han Xiaolin, a senior volcanologist in the project, summed it up with eerie clarity. The question isn't whether the mountain is angry. The question is whether it's about to speak. On May 24, 2018, North Korea made a grand announcement. It would shut down the Punggye-ri nuclear test site. 20 journalists were flown in from around the world. No inspectors, no geologists, just the press. From 1,640 feet away, they watched as controlled explosions sealed the tunnel entrances. The south portal, the east portal, the west portal, one by one, each was destroyed in a carefully choreographed display. The message was clear: we're done testing. But when the dust settled, the truth was harder to bury. The entrances were sealed, yes, but the mountain was already broken. The damage had been done deep inside, where cameras couldn't see. Satellite monitoring from independent agencies confirmed what scientists feared. Mount Mantap was still shifting. Tiny tremors continued. Rock formations were slowly degrading. The internal fractures caused by the 2017 blast hadn't healed. In fact, they were worsening. The mountain, once a symbol of permanence, now stood as a warning. Its shape was forever altered, its height 20 inches shorter than before, and inside a minefield of radioactive scars that no one could reach, let alone undo. Environmentalists called it geological vandalism, a mountain destroyed for a moment of power. But it wasn't just about Mount Mantap. It was about what it symbolized. In South Korea, protests continued. In Japan, defense budgets rose. In China, border monitoring remained quietly intense. And in living rooms across the world, one question lingered. If one test could move a mountain, what else are we shaking loose? Because it wasn't just tectonic plates or volcanic chambers being disturbed, it was the Earth's balance. Since the dawn of the nuclear age, over 2,000 nuclear tests have been conducted on this planet, most of them underground, many in remote deserts or uninhabited islands, but all of them left footprints on the environment, on the atmosphere, and deep within the crust of the Earth. Dr. Lynn Sykes, a veteran seismologist who spent his life studying nuclear test impacts, didn't mince words. The 2017 North Korea test was a threshold moment. It showed us we don't just have the power to destroy cities, we have the power to break the planet beneath our feet. After the tunnel demolitions, North Korea went quiet. No more tests, no more press releases, no more shaking mountains. But silence doesn't always mean safety. To this day, Mount Pektu is still under watch. Volcanic activity remains elevated. Seismic patterns are abnormal. Gas emissions fluctuate without explanation. No eruption yet. But volcanologists haven't exhaled because the Earth has a memory and it doesn't forget what was done beneath its skin. Mount Mantap still stands. Shorter, cracked, unstable, but still there. A grim monument to one of humanity's most dangerous experiments. It doesn't need plaques or fences to remind us. Its broken spine does the talking. Its slow tremble tells the truth. We moved a mountain. We cracked the crust. We played with power we didn't fully understand. And now, the Earth waits. We used to believe mountains were immovable, eternal, unshakable. But in our quest for dominance, we didn't just split atoms. We fractured stone. We unsettled volcanoes. We proved we could literally move the Earth. But the real question is, at what cost? And what ancient forces, beneath our feet and within ourselves, have we awakened in the process? Only time and the restless Earth will tell. If this story shook you, share it. Let others see what happened on that mountain in 2017, because these aren't just headlines or history lessons. They're warnings, like if you learn something new. Subscribe for more stories about the hidden forces shaping our world, and let us know in the comments, do you believe humanity will ever learn to wield this kind of power responsibly?